We have conquered the moon, sent spacecraft to Mars, even reached the edge of the solar system. However, today, in the era of artificial intelligence and modern space telescopes, why have we still not been able to set foot on Pluto or the nearest star, Proxima Centauri? In reality, the limits of physics, energy, and time are posing enormous challenges. If we fly at the speed of a commercial airplane, about 900 kilometers per hour, it would take nearly 8,000 years to reach Pluto, the farthest planet in the solar system. That is an extremely long period of time, far beyond any journey humanity has ever made. Moreover, Proxima Centauri, although only about 4.24 light-years away from us, is also a difficult target. Even with the most advanced technology today, such as the Parker Solar Probe spacecraft, we would still need tens of thousands of years to get there. Will we ever be able to overcome these barriers to explore the mysterious worlds that are waiting? If Pluto is humanity's final frontier within the solar system, where sunlight fades and time grows dense, then the exoplanets beyond, the worlds never seen by the naked eye, are invitations to a farther horizon of understanding. Out there are no planets orbiting the sun, no familiar rules of light, temperature, or life. Instead, there are countless possibilities, other forms of being in the universe, where everything we know about physics, chemistry, and even existence itself is put to the test. Since the mid-1990s, when Michel Mayor and Didier Queloz discovered the first planet outside our solar system, 51 Pegasi b, humanity officially stepped out of its own shadow. That planet is a hot Jupiter, as massive as Jupiter but orbiting so close to its parent star that 1 year lasts only 4 Earth days. Its atmosphere boils, with winds reaching thousands of kilometers per hour. From that discovery, a new era began. Thanks to the Kepler Space Telescope, launched in 2009, humans for the first time looked into the darkness between the stars. Kepler observed more than 150,000 stars, and to this day astronomers have confirmed over 5,600 exoplanets, worlds orbiting other suns. There are planets where glass rains from the sky, such as HD 1897-33b, where the blue shimmering atmosphere hides winds blowing at 7,000 kilometers per hour, flinging molten glass shards sideways like knives. There are planets as black as coal, like TRES 2b, absorbing 99% of all light, rendering them nearly invisible even next to a blazing star. And there are worlds where iron condenses and falls as rain, like WASP 76b, where day and night are eternally divided. One side burns at 2,400 degrees Celsius, while the other lies in endless darkness. The universe seems to be taunting human imagination. It creates worlds that should not exist, yet somehow they do. And yet, among all those impossibilities, there are planets that leave scientists breathless. Not because they are strange, but because they are familiar. In 2016, the ESO telescope in Chile discovered Proxima Centauri B, a rocky planet orbiting the star closest to Earth, just 4.24 light-years away. It lies within the habitable zone, a region where water could exist in liquid form. A world that might have oceans, an atmosphere, and perhaps life. The news was shocking, but the truth is harsher than imagination. Even though it is close, only 4.24 light-years away, that distance equals more than 40 trillion kilometers. With current technology, humanity would need over 80,000 years to reach it, even aboard the fastest spacecraft, New Horizons. We can see it, calculate its orbit, yet never touch it, though humanity conceived even more audacious ideas. The Breakthrough Starshot Project, initiated by Stephen Hawking and billionaire Yuri Milner, proposed using ground-based lasers to propel light sails, tiny spacecraft weighing just a few grams, to 20% the speed of light. If successful, they could reach Proxima B in about 20 years. It sounds plausible, but pushing even a small object to such speeds would require an energy output equivalent to a massive nuclear power plant running at full capacity, and a deviation of just a few millionths of a degree could send the craft billions of kilometers off course. A planet at the perfect Goldilocks distance, possibly harboring water, yet scorched by flares from its red dwarf star, radiation hundreds of times stronger than the sun's. A planet the same size as Earth, yet tidally locked, with one half melting under eternal heat and the other frozen in perpetual darkness. Then, in 2023, the James Webb Space Telescope opened a new chapter. With its superior infrared vision, Webb not only saw these planets but smelled their atmospheres. It detected water vapor, methane, carbon dioxide, even traces that could hint at biological reactions. But it was here that Webb's first data puzzled scientists more than it thrilled them. Some planets that should have stable climates were too hot. Others that couldn't possibly have water showed signs of moisture. Yet perhaps the greatest paradox lies not out there, but within ourselves. For even after creating machines that can see across billions of light years, humanity still does not understand the meaning of its own existence. We search for planets with life while destroying the only living planet we know, Earth, every single day. We dream of reaching Proxima Centauri, yet cannot preserve the fragile ecological balance beneath our feet. The strange worlds beyond may serve not as promises, but as reminders. They force us to confront a question no telescope can answer. Is human intelligence truly capable of transcending its own nature? Its instinct for self-destruction? If Pluto is the ultimate test of physical limits within the solar system's backyard, then Proxima Centauri is the mirror that reflects the boundary of all humanity. So close, it feels like we could reach out and touch it, yet in truth, it is farther than imagination itself. We know its position precisely, its orbit, its mass, its brightness, even the planet that circles it. Proxima B, believed to contain liquid water, an environment where life could possibly exist. But all that knowledge is just light that left that star long ago. It means that every time we look at Proxima Centauri, we are looking into the past. And that past lies 4.24 light years away, nearly 40 trillion kilometers, a number so vast it defeats human imagination. That distance may sound close when we speak of stars, but if we launched New Horizons, the fastest spacecraft ever built by humans, in that direction, it would need 80,000 years to arrive. In other words, if we had launched it during the time when Neanderthals still walked the Earth. Only now would it be reaching the first rays of light from Proxima. Even if we accelerated it 100-fold, the journey would still take more than 400 years, longer than the lifespan of any civilization that has ever existed. And here lies the first great paradox. The nearest star is also the one we cannot reach. When Einstein announced his special theory of relativity in 1905, he not only opened a new age of physics, he also, perhaps unknowingly, locked humanity inside the cage of light speed. Nothing with mass can ever reach or surpass the speed of light, because to do so would require infinite energy. In other words, to reach Proxima Centauri within a human lifetime, we would have to break the very fabric of reality itself. But in 2016, the breakthrough Starshot project was born, backed by Stephen Hawking and physicist Yuri Milner. The plan envisioned thousands of nanospacecraft, each weighing only a few grams, propelled by gigawatt-class laser beams from Earth, accelerating to 20% of the speed of light. At that velocity, they could reach the Alpha Centauri system in just 20 years. A beautiful and insane idea. Because while lasers can send the craft forward, no one knows how to stop it. There is no fuel, no braking system. We can send them out, but we cannot bring them back. Just like New Horizons once flew past Pluto without stopping, Starshot may be nothing more than a quick, radiant brush with the cosmic door, before vanishing into the void. And the true tragedy is this: even at 20% the speed of light, a single dust particle could unleash the energy of a small nuclear explosion upon impact. No known material today is strong enough to withstand that. Each cubic meter of interstellar space contains dozens of microscopic dust particles, and at that velocity, each one becomes a deadly bullet. The universe, seemingly empty, is in fact a vast invisible battlefield filled with death. Even more daunting, a minuscule deviation, a degree as small as 0.001 degrees at launch, could throw the spacecraft billions of kilometers off course by the time it arrives. We would not only need to shoot the star across light years of distance, but also predict its future position, knowing that its light takes years to reach us. Though technologically impossible for now, Proxima Centauri continues to hold a near-religious fascination. Around it, astronomers have discovered Proxima B on a planet nearly the same mass as Earth, orbiting within the liquid water zone, where life, at least as we understand it, might exist. But the truth is, Proxima Centauri is a red dwarf, a small, cooler, and extremely unstable type of star. It emits intense ultraviolet and X-ray radiation, hundreds of times stronger than what Earth has ever endured. Each stellar storm could strip away Proxima B's atmosphere in just a few million years, blowing off every molecule of water and oxygen. A research team from the University of Geneva in 2020, using data from the espresso spectrograph on the Very Large Telescope, confirmed the existence of Proxima B. They also suspected a second planet, Proxima C, larger and farther out, possibly so cold that its entire surface is frozen. A frozen world orbiting a red sun? The nearest star, the most Earth-like planet, and yet, perhaps, the harshest place imaginable. Scientists can calculate the mass, orbit, and even the possible atmosphere of Proxima B, but they cannot see it. All the data we have are tiny fluctuations in the light of its parent star, measured through the Doppler effect. Every figure represents billions of calculations, born from ancient photons that traveled across light years to strike our sensors. All we truly see is the bent light of the past. Perhaps, in the moment we send our first nanoship toward Proxima, somewhere out there, another civilization, if it exists, is doing the same, sending light toward us. Two signals crossing paths in the void, never touching, yet leaving behind one eternal question. Are we truly alone, or just too slow to meet each other? Proxima Centauri teaches us a profound lesson. Human progress is not limited by intelligence, but by time and energy. Every dream of reaching the stars must be paid for in generations of waiting. If Pluto is the harsh challenge within the backyard of our solar system, and Proxima Centauri is the invisible wall separating us from the stars, then the true barrier lies not merely in distance or speed. Every dream of interstellar travel shatters before Einstein's special theory of relativity. The speed of light, 299,792 kilometers per second, is not a target to be achieved, but an absolute limit. No object with mass can ever reach or surpass it. As an object accelerates, its mass increases exponentially, to reach the speed of light, the required energy becomes infinite. The closer we get to light, the more tightly we are bound by the laws of physics, imprisoned by limits the universe set billions of years ago. Even aiming for just 10% of light speed, a fraction of the ultimate limit, is a nearly impossible challenge. To accelerate even a small spacecraft to that velocity, we would need energy equivalent to thousands of years of the entire Earth's electrical production. Imagine a civilization expending its millennia of progress just to push a tiny machine through the cosmic void. Would humanity ever be willing to sacrifice its entire planetary resources for a voyage to the stars? But energy is not the only problem. Interstellar space is far from empty. It is a sea of subtle violence. Cosmic radiation, composed of high-energy particles from supernovae and black holes, can destroy human DNA and permanently damage electronics. Interstellar dust is a silent but merciless enemy, a particle smaller than a pinhead. Colliding with a ship moving at 20% the speed of light carries energy equivalent to a small nuclear explosion, enough to tear sails apart or puncture the hull. The universe, though seemingly tranquil, is a high-speed battlefield where every object is prey to the laws of physics. The challenge runs even deeper with time and durability. A journey to Proxima Centauri would last hundreds, even thousands of years. No material on Earth could survive such a span in that environment. Every metal, every synthetic compound would gradually degrade, erode, and crack under the constant assault of radiation and interstellar particles. The spacecraft would become a drifting wreck long before ever reaching its destination. Modern science can calculate design and predict. We can imagine a nano spacecraft, like in the Breakthrough Starshot project, sailing on laser energy at 20% the speed of light, reaching Proxima Centauri in just about 20 years. But even if the theory works, the technology remains an abyss. How can a nanolight sail survive collisions with interstellar dust without disintegrating? How can it maintain trajectory in a weightless void where even a microscopic impact could send it billions of kilometers off course? And more importantly, how can we collect data when every signal sent back to Earth would take over 4 years just to arrive, creating a delay beyond human patience? The irony is that every step we take toward those distant planets reveals new paradoxes. Proxima B, potentially harboring liquid water within its habitable zone, orbits a star that unleashes massive radiation storms capable of stripping away its atmosphere within geological time. A planet that seems perfect for life may, in truth, be a cruel testing ground, where every flare is a reminder that life beyond Earth may be rarer than we dare to believe. Where a place seems ideal, it may be a trap. Where it appears lifeless, it could hide opportunity. The so-called super-Earths, some with oceans hundreds of kilometers deep and pressures thousands of times that of Earth, prove this paradox. Some of them have magnetic fields hundreds of times stronger than Earth's, strong enough to protect their atmospheres, but unpredictable enough to make any forecast of climate or oceans uncertain. LHS 1140b, located 40 light-years away, is considered one of the best candidates for habitability. But even at our fastest speed today, humanity would need over 200,000 years to reach it. And perhaps the most profound reflection of all, science not only brings our dreams closer to reality, it also reveals our helplessness. Each new planet discovered does not open a door. It reminds us that the universe is millions of times greater than our reach. Every piece of data from James Webb, TESS, or Kepler is a cold echo from afar. Those brilliant worlds are nothing but frozen lights. Places where life, if it exists, endures silently under the relentless rule of physics. The exoplanets beyond, from scorching gas giants to icy rocky worlds, are not just distant points of light. Mirrors reflecting the deepest longing of humanity. If the previous section revealed the physical and technological walls that separate us from the stars, then now we must confront a deeper, more intimate challenge: time and human perception. Interstellar space may be cold, and radiation may be destructive. But the true barrier lies within our own biology, psychology, and society. Imagine a journey to Proxima Centauri, the nearest star beyond the Sun. The distance of 4.24 light-years seems small on an astronomical map. Yet in reality, with any existing technology, the voyage would take centuries. This is no longer an ordinary journey, it is a voyage across generations, where those who depart will die long before their descendants ever glimpse the destination. Generations born aboard the ship, never having breathed natural air or seen Earth, would live out their lives inside a cold steel vessel drifting through infinite space. Here arises a profound psychological and social paradox. How can hope, purpose, and order be maintained within a closed community where every effort is devoted to a goal that none will ever witness? Theoretical models of generation ships have been proposed by scientists since the 1970s. But most have concluded that sustaining a small society on a centuries-long voyage is almost impossible. An unprecedented moral and governance challenge in human history. Yet the problem extends beyond society itself. Human perception also builds an invisible wall. We are born and live according to the rhythm of a lifetime. We measure time in weeks, months, and years. rarely imagining spans that stretch beyond personal existence. Meanwhile, the universe moves in the rhythm of billions of years. Earth is 4.5 billion years old. Proxima Centauri is just 4.24 light-years away. The number seems small, but in the rhythm of human life, it is a temporal abyss. One, our minds and biology cannot fully grasp. We know the distances, we can calculate orbits, and we can even dream of the stars. Yet it is our own consciousness and biology that make those dreams nearly impossible. Humanity is a species born to live and die by the cycle of sunrise and sunset. To reach the stars, we would not only need powerful spacecraft, we would need to alter our very biological, psychological, and perceptual nature. They remind us that, in our quest for exploration, the true frontier is not made of planets or stars, but of endurance, awareness, and patience. Earth is 4.5 billion years old. Proxima Centauri is only 4.24 light-years away. The distance may be small on a cosmic scale, but it lies far beyond our biological, psychological, and social limits. No material or technology can replace the ability to preserve culture, education, and social values across generations, far from Earth. A machine may endure, but a biological and spiritual society may not. Those planets and stars are not merely physical destinations. They are mirrors reflecting the intelligence, ambition, and fragility of humankind. In the silence and mystery of the space between stars, humanity learns that to venture beyond the solar system, we must first expand the boundaries of perception. To learn endurance in solitude, to find meaning in time unending, and to discover purpose even before touching the distant stars. Pluto and Proxima Centauri stand as two opposing symbols. Not merely representations of physical distance, but reflections of the deepest limits of human knowledge and existence. On one side lies Pluto, the frozen world at the edge of the solar system, close enough to see, yet requiring a journey lasting decades to reach. A voyage in which even our fastest probe can only glance past it in the blink of cosmic time. On the other side, Proxima Centauri, the nearest star beyond the Sun, 4.24 light-years away, stands as an unbreachable wall of physics, defying even the boldest ideas of our age. From Pluto's perspective, the Sun appears only as a dim point in a black sky, a faint shimmer in the endless void. Likewise, Proxima Centauri is but a tiny glint in the interstellar darkness. Both, though at opposite extremes of space, mirror the same truth. The limits of human perception control, and conquest. They are harsh reminders that no matter how far science and technology advance, we remain bound by the laws of nature, by hostile environments, and by the confines of our own awareness. We once believed that reaching another planet or star was merely a matter of speed, engines, or fuel. Every small step forward, every solitary discovery among distant planets marks a greater leap in awareness and comprehension for humankind. In the light of these two extremes, Pluto and Proxima Centauri become dual symbols, both scientific challenges and philosophical reminders. They teach us that science is not only about measuring and discovering, but about recognizing both our potential and our limits. And until we transcend the barriers of mind and biology, they will remain distant stars, cold yet necessary reminders of where we stand, what we long for, and the next steps humanity must take to one day truly reach the stars. Thank you for staying with WUFO Space until the very end of this journey through the vast universe. If you found this video interesting and insightful, don't forget to like, share, and subscribe to WUFO Space so you won't miss our next cosmic adventures. Your support means the world to us and fuels our passion to keep exploring the wonders beyond.